Okay, before we get to our unit vectors, we need to talk about position vectors. And depending on what your coordinate plane looks like, depends on maybe where you would place your vector. And so a position vector is basically there to give you the stats of a vector, its x and y components, so that no matter where it is on the coordinate axis, you know exactly what you can, how large it is and what direction. So an algebraic way of representing vectors is by using components and a position vector. So an algebraic vector is represented as v equals, and then you'll notice you have these brackets here, kind of look like a spaceship, where a and b are real numbers. They're scalars called components of the vector v. If the vector's initial point is at the 0, 0, and the terminal point is at AB, then V is called a position vector. So essentially, anywhere you start that vector, let me erase that here, anywhere I would start that vector, if I place an origin exactly there and I have that vector, right? If I have a vector here and then I want to say that this is where my origin is or where I'm going to consider 0, 0, and then I would be over 2 and up 1.5. So this would be 2, 1.5 as my position vector. All right. A position vector describes the horizontal and vertical movement of the directed line segment from the initial point. So here we are going to, I'm going to actually get this erased because we're going to do an activity here. Plot the points P1 and P2 with P1 as the initial point and P2 as the terminal point. So here is my first point. So negative 3, 1. So that's this one right here. And then point 2 is 6, 3. So 6, 3 is right here. And so I want to connect them this way. Okay, so that is my vector. And if I consider this 0, 0, okay, then I'm going to determine what my position is. So I go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9. And then I go up 1, 2. So that would be 2. So my position vector would be 9, 2. And it has a little bit here from the initial point to the terminal point, determine the horizontal and vertical movement. We did that. And so we have 9, 2. The other way you can do that is take your plot points, right? You can say that you have your point 2. So x2 minus x1 is going to give you your x value. And then x or y2 minus y1 is going to give you your y value. Okay, so let's go ahead and go through that. We have, with our points here, my x2 would be 6 minus a negative 3. So minus a negative would give us a 9. And then 3 minus 1 would give us a 2. So we get those numbers by finding our difference between those points as well. So you could do it either way, especially if you have a graph and you can count it, super easy. If you don't have a graph and you need to figure it out, you can do it this way. All right, so that above is the position vector if the initial point was at the origin and the horizontal and vertical movements were applied. The two vectors would have the same magnitude and the same direction, and thus be the same vector. The results from part 2 of exploration 3 can be summarized as follows. So we just did this. If we have two different points and we want to find our vectors, we have x squared, or x2, minus x1, and y2 minus y1. So that's how we got it mathematically over here, and that would be our summary that we have on this page.